are given, then you are arranging the data in either ascending order or descending order, you can say. And if character data is given, then sorting means to arrange that data alphabetically. Fine. Many sorting techniques are there: bubble sort, insertion, selection, quick, merge, radix, shell, heap sort. Okay, we'll discuss all the sorting techniques one by one. In this video I am going to discuss with you what is bubble sort. First of all, we'll discuss the working principle of this bubble sort with the help of an example, how bubble sort works, how the data is to be sorted using this technique. Then we will write down the code, and after that we will see what modification we can make in that algorithm of bubble sort for improving that algorithm. Okay, now first of all, let us take one example. Suppose data is given 15, 16, 6, 8 and 5, and this data is stored in an array. Suppose the array name is A. So the index would be from 0, 1, 2, 3, 4, something like this. Okay, number of elements are 1, 2, 3, 4, 5. So suppose n is equal to 5. Number of elements are n and n is equal to 5. Now, what is the basic principle of bubble sort? In this case, the two adjacent elements are to be compared. If those elements are in correct order, then it's fine, we'll move further. And if those elements are not in correct order, then we will swap these elements. Now, what do you mean by this incorrect order? See, it depends. You are sorting the data in ascending order or descending order. Now, here by default, if I say sorting, then here I mean we are going to arrange the data in ascending order. Fine. So the question is, the data is given, one array is given having these elements, and you are going to arrange this data in ascending order. You are going to sort the data in an ascending order using bubble sort. Okay. Now, what is the simple funda in bubble sort? We are going to start from first element, and in bubble sort, this first element is compared with the second element. Fine. And if these elements are in incorrect order, these are not in correct order, then we are going to swap these elements. Then next two adjacent elements are to be compared, then next two adjacent elements are to be compared, and next two adjacent elements are to be compared. Fine, until we reach to the last of the array. So now, according to the bubble sort, first of all, these two elements are to be compared. A of 0, name of the array is A of 0 is compared with A of 1, or you can say in bubble sorting, A of name of, suppose array is this A of I is compared with A of I plus 1. Fine. And if these two elements are in wrong order, then they are to be swapped. And if these elements are in correct order, then no swapping would be done. Fine. Now see, 15 and 16 are to be compared. We are going to arrange the data in ascending order, then no swapping would be done. So after that, after this comparison, the array would be something like that: 15, 16, 6, 8 and 5, because no swapping is to be done. Fine, because 15 is less than 16, so 15 and 16 are in correct position. Now next is A1 and A2 are to be compared. Fine. Now see, these are in wrong order, so we are going to do swapping. So 6 would be at this place and 16 would be at this place. So after swapping, the array would be 15, 6, 16, 8 and 5. Now next is these two elements are to be compared, A of 2 and A of 3 now. Now in this case also swapping would be done, because 16 is greater than 8, so 16 would be at this side. So the array would be 15, 6, 8, 16 and 5. Next comparison is this with this one. Now also swapping would be done. Now the array would be 15, 6, 8, 5 and 16. Okay. Now this is known as this complete is known as pass 1. And here you can see the largest element from this array has bubbled up to its right position, to the end of the array. After completion of pass 1, the one element which is the largest element has bubbled up to its correct position. Okay, that is why it is known as bubble sort. Okay, so now one element is in its correct position. Fine, and this complete is known as pass 1. Now we are not still done with the sorting, because the array is now this, and this is not a sorted array. Now after this, again we are going to start from first element. Okay, after pass 1 we are going to start pass 2, and now in pass 2 array is 15, 6, 8, 5 and 16. Fine, same apply the logic of bubble sort. Two adjacent, we are going to start from the 0th element, and two adjacent elements are to be compared. If they are in correct position, then no swapping would be done. If these elements are in wrong position, then swapping would be done. Now start from here only. First of all, we will compare 15 and 6. So swapping would be done. Yes, 6, 15, 8, 5 and 16. Next, these two elements would be compared. Swapping would be done. Yes, 6, 8 this side, 15, 5 and 16. Next, these two elements would be compared. Swapping would be done. Yes, 6, 8, 5, 15 and 16. Next, these elements is to be compared. 6, 8, 5. Swapping would be done. No, 15 and 16. Now we have reached to the end of this array. Now this is pass 2. Now after completion of pass 2, see two elements are at its correct position. This is the largest element and this is the second largest element. Now these two elements are at its correct position. Now remaining elements are these three elements. Now again we are going to repeat the same step. We are going to start from the here only, from the 0th position, and we are going to compare adjacent elements, because still we are not done with the sorting. So now in pass 3, see, now array is what? 6, 8, 5, 15 and 16. Now again we are going to start from this to this, from starting only, starting element. Swapping would be done. No swapping would be done. So the array is 6, 8, 5, 15 and 16. Next, these elements are to be compared. Swapping would be done. Yes, 6, 5 here, 6, 8 this position, 15 and 16. Next, these elements 6, 5. Swapping would be done. No, 8, 15 and 16. Next is this one and this one, 6, 5, 8. No swapping would be done, 15 and 16. Now we are reached to the end of the array. Now this is pass 3. Now after pass 3, three elements are at its correct position. Largest, second largest and third largest. Now remaining are two elements. Now next pass would be pass 4. And in pass 4 array is 6, 5, 8, 15 and 16. Now again same steps would be repeated. From the 0th element, the comparison would be done with the adjacent element. Here swapping would be done. Yes. So after swapping, array would be 5, 6, 8, 15 and 16. Next this with this. 5, no swapping, 6, 8, 15 and 16. Next with this one. 5, 6, no swapping would be done, 8, 15 and 16. Next with this one. 5, 6, 8, 15 and 16. Now this is the array. Now we have reached to the end of the array. Okay. Now this is what the sorted array. After pass 4, these four elements are its correct position, and total elements are 5, then obviously you can say, it's common sense, if 5 elements are there, then you need to sort only 4 elements, then obviously the 5th element would automatically be at its correct position, right? So now we have sorted these 4 elements, so this element, the 5th element, is automatically at its correct position. So now this array is now sorted. How many passes you require? 1, 2, 3 and 4. To sort how many elements? 5 elements. Okay. So how to calculate how many number of passes required? Number of elements minus 1. If number of elements are 6, then how many passes would be required? 5. Number of elements are 10, the number of passes would be 9. Okay, we will modify this also. It's not like that if number of elements are 10, then those elements would be sorted in 9 passes only. Okay, that is not a rule. We are going to see that case also. Okay, this is the general case. If n elements are there, then in bubble sort, these steps would be repeated how many times? N minus 1 times. See now, within this pass, how many comparisons are there? 1, 2, 3, 4. 4 comparisons, right? Within this pass also we have 1, 2, 3, 4 comparisons. Within this pass 1, 2, 3, 4. This pass 1, 2, 3, 4. So 2 loops would be there. One loop is for passes 1, 2, 3, 4. And second loop is for these comparisons, or you can say iterations. Fine. Within the pass, how many comparisons are there? So one outer loop is for passes, and within the passes one inner loop would be there for these comparisons. Fine. Now how to write the code? Write down the outer loop. For suppose we are taking one variable I is equal to, outer loop is for these number of passes, and how many times this loop would be executed? N minus 1 times, right? Because number of elements are here 5, number of passes are 4, that is n minus 1. So this loop would be executed for how many times? N minus 1 times. So if we are going to start I from 0, then I should be less than n minus 1 and I plus. I hope you got the concept. Okay, here suppose I is from 0, so here you can say this pass is for I is equal to 0. When I is equal to 1, then this pass. When I is equal to 2, then this pass. And when I is equal to 3, then this pass. Okay, that is why I am taking I is equal to from 0 to less than n minus 1. Here n is 5 minus 1, that is 4. So I is less than 4. It means I is equal to till I is equal to, or you can say I is till 3. If you take I is equal to 1, then you can say I is less than equal to n minus 1. Now within this loop, one inner loop would be there, that is for suppose j is equal to 0, and this loop is for these comparisons. So how many comparisons within each pass? 1, 2, 3, 4, 4, 4, 4 and 4. It means n minus 1 comparison. So you can say j is less than n minus 1. Same. Fine. We are going to start from 0. That is why I am taking j is less than n minus 1. If you write here j is equal to 1, then you can say j is less than equal to n minus 1. And here you will write j plus. Fine. Now the main logic is what? Now we are going to check if this element is greater than this element, then you do what? Swapping. Fine. See here, this case you can say here no swapping is done, but here this element is greater than the next element. So that is why we have done what? Swapping. So here what you will check, if name of this array is A of j is greater than A of j plus 1, then you do what? Swapping. And swapping is I guess you know the logic. You just take a temp variable and do the swapping. So we do what? Temp is equal to A of j, and A of j is equal to A of j plus 1, and then A of j plus 1 is equal to temp. This is the simple logic of swapping. Fine. This is for if, this is for this for loop, and this is for outer for loop, like this. But now you can modify this logic. How? See, here how many comparisons are there? 4 comparisons. But after pass 1, the largest element is at its correct position, right? So in this pass, do you really need to compare 15 with 16? I guess no. Why so? Because we know that the last element is the largest element. So no need to compare this element, because we know that this element is always less than this element and no swapping would be done. So here no need to do this comparison, right? In this pass also, see, now after pass 2, these 2 elements are its correct position, the largest element and the second largest element. So here we know this is the largest element, this is the second largest element. Fine. Then do you really need to compare 8 with 15? No, because these elements are its correct position. These are the 2 largest elements. So we can say that obviously this element would not be greater than this element. So no need to compare this, and obviously then no need to do this comparison. Fine. So in this pass only 2 comparisons are required. In this pass only 1, 2, 3 comparisons are required. And in this pass, see, after pass 3 elements are in its correct position. So you can say this array is sorted and this is unsorted. Now you just have to compare these elements because these are already sorted. So in this case we only need this comparison. We don't need this comparison, we don't need this one, and we don't need this one. No need to compare this element with this one, because we know this is the third largest element and this element cannot be greater than this element. So why we are comparing this element? We are only increasing the computation time. No need to do this comparison. Fine. Now how to modify this code? See, this number of comparison depends on this I value, because when I value is 0, then how many comparison? N minus 1 comparison. But when I value is 1, then only 1, 2, 3, 3 comparisons. It means 1 comparison less. So when I value is 2, then how many comparisons? Only 1, 2 comparisons. So you can say when I value is increasing, number of comparisons are decreasing. So these number of comparison depends on I value. Fine. And for number of comparison, which loop is there? This inner loop is for number of comparisons. So we can modify this inner loop. We have to modify this inner loop. Now how to modify this loop? This loop, now this loop is not dependent on this I, because we are just going to start j with 0 and then we are going to increase the j value till less than n minus 1. So now you can do what? Here you can write n minus 1 minus I. N minus 1 minus I. If you do this case, then that unnecessary comparisons can be avoided. So how this will work? See, let us take one case. Let us take I value is equal to 2. Fine. 2 is less than n minus 1. N minus 1 is what? N is 5. 5 minus 1 is 4. Yes, this condition is true. 2 is less than 4. Then we will go to this loop. J is equal to 0 now. J is equal to 0. So j is less than n minus 1 minus I. N is equal to 5. 5 minus 1, 4. 4 minus I value is 2. 4 minus 2 is 2. Yes. 0 is less than 2. Yes. Then we will enter this loop. Now we compare what? A of 0 greater than A of 1. Now see, I is equal to 2. A of 0 greater than A of 1. No, this condition is not true because 6 is less than 8. Fine. So we will not enter in this condition, because this condition is not true, so we will not enter here. Finally, what should be done? J plus plus. Now j is 1. Now here what is there? 5 minus 1 minus 2, that is 5 minus 3 is 2. Now 1 is less than 2, yes, we will enter again this loop. Now we will check a of, now j is what? 1, j is 1 greater than a of j plus 1 is 2. Now check, a of 1 is this one and a of 2 is this one. A of this one, 8 is greater than 5, yes, then swapping would be done. So we have done the swapping 5 and 8. Now j value will be increased, now j is equal to 2, but 2 is not less than 2. So now we will not enter into this loop, this condition is not true, and we will go out from this loop and I plus plus. Now I is equal to 3. How many comparisons are there? 1 and 2 only. So in this case, how many comparisons are required? 1 and 2 only, because 15 and 16, I have already told you this comparison not required, this comparison is also not required. Fine. So this is how you can avoid the unnecessary comparisons, only by writing here n minus 1 minus I. This is why we write here n minus 1 minus I. Now one more modification you can do in this algorithm, and that is known as optimized bubble sort. Now what is that modification? See, in this case, how many passes, after how many passes you got the sorted array? After 4 passes. You can say after n minus 1 passes. But every time this is not true. Maybe sometimes 10 elements are there and only after executing 3 passes you got the sorted array. Fine. But when you apply this logic, then this program would be executed for how many times? N minus 1. You can say if n is equal to 10, then for 9 times this is to be executed. Fine. And if suppose this all the elements has been sorted after the 3rd pass only, then remaining passes are wastage of time, na? So what you can do is, so to get this point, let us take one more example. See, now we are going to take one more example. See, suppose this is the array 16, 14, 5, 6 and 8. How many elements? 5 elements. Okay. Now according to this case, how many passes would be required? This numerical, or you can say this program would be executed for how many passes? 4 passes. N minus 1. Fine. Now see, when you apply the bubble sort, then you see that in pass 1, yes, swapping is done, we got the largest element here. In pass 2, we have just done 3 comparisons and 2 largest element are there. And in pass 3, see, when you are comparing 5 with 6, no swapping is there. When you are comparing 6 with 8, no swapping is there. And already 14 and 16 are its correct position after pass 2. So you just have to sort these 3 elements. We compare 5 with 6, 6 with 8. No need to compare with 14 and 16. So here no swapping is there. So in this pass only 2 comparisons are there, because we are going to write down this condition, okay, n minus 1 minus I. So in this pass no swapping is there, and after this pass only we got the sorted array. See, 5, 6, 8, 14 and 16. But according to this program, pass 4 is going to be there. Although we know that in pass 3 only we got no swapping and we got the sorted array. But when you apply this case, then pass 4 would be executed. One comparison would be there for this 5 and 6. But that is of no use, because we know that after pass 3 only we got the sorted array. So we have to modify this program. How to modify this program? We have to check if you got any pass in which no swapping is there. See, in which no swapping is there, then you can say that, then you can break this loop. You can break this loop and you can say that now array is sorted. If, see, in this pass one swapping is there, 14 and 15, yes, this swapping was there. So here we got one swapping. Here also we got swapping, but in this pass no swapping is there. So we can say that now the array is sorted, no need to do any other passes. So how to check that condition? So we can take one flag variable, fine. Now in starting in this loop, suppose after this loop we are going to set this flag variable is equal to 0. And now if swapping is done, then you can set this variable as 1. So the code for swapping is here only. So if the control has entered here, it means swapping has been done. If swapping has been done, then you can set this variable within this if condition, flag is equal to 1. After this if is to be closed, flag is equal to 1, fine. If flag is equal to 1, then it means swapping has been done and you cannot stop this loop, fine. And if sometimes it happens that no swapping is done, if no swapping is done, then control will not enter here, fine. So the flag variable will not be set to 1, flag variable will remain 0, right. So you can check here, see here, after this if and after this for, fine. After this you can check if flag is equal to 0, then you can say break, and after that you will close the outer loop here only. If flag is 0, then break, break means from this loop you will go out, and you can here print that array is sorted. This is not the complete code, I am just writing the logic. Obviously you have to declare one array A, size of the array n, the flag variable and something like this. So this is the optimized bubble sort. So now let us trace out this program with the help of one example. Let us take one I value is equal to suppose 2. See, when I value is 0, so I value is 0 for this pass, I value is 1, for this pass I value is 2, because we are going to start I from 0. So let us take I value is 2. Now if this code is correct, if we have written the flag variable and we have checked the flag variable at the right position, then you find out that I value would not be increased to 3, because if we don't write this flag variable, this code, then how many passes would be there? 4 passes would be there, and I would be increased from 0 to 3. But if you write down this code and if this code is correct, then I value would not be increased to 3. The outer loop would be executed for I value 0, 1 and 2, only for I value 2, because after this pass only we got the sorted array, fine. Now check, when I value is 2, so 2 is less than n minus 1, n is 5, 5 minus 1, that is 4, so this condition is true. Now control will go to this loop. So now see, flag is equal to 0, one variable is there, flag, and the value of that is 0, fine. Now j value is equal to 0, j is equal to less than n minus 1 minus I, so this is what, 0 is less than n is equal to 5 minus 1 minus I value is 2, so 5 minus 3, that is 2, this condition is true. So control will go within this loop. Now check, a of j value is 0, a of j greater than a of 1, here when I value is 2, fine. A of 0 greater than a of 1, is 5 greater than 6? No, this condition is not true. So the control will not go within this condition, fine. Now if this condition is not true, then again what will happen, j plus plus. Now j is equal to 1. Now 1 is less than 5 minus 1 minus 2. Yes, 1 is less than 5 minus 3 is 2. 1 is less than 2. Yes, this condition is true. So control will go within this loop. Now check, if a is equal to j is now 1 greater than 2. Now see, a of 1, a of 2, is 6 greater than 8? No, this condition is not true. So control will not go within this within these conditions, within this if statement. Now j plus plus, if control will not go within this condition, then the next condition is, the next statement to be executed is j plus plus. Now j is equal to 2. Now condition is 2 less than 5 minus 1 minus 2, 2 less than 2. This condition is not true now. Fine. So now control will not go within this for statement if the condition is not true. Fine. Now where control will go? Now control will go to here only, because after j plus plus is not true. So control, if you will not write this one, the finally control will go here only, I plus plus. But now we have two more statements in this for loop, within this for loop, within this outer for loop. Fine. So now control will go here, and now we will check if flag is equal to 0. See, flag variable is 0. It has not been updated. Why? Because in this case the control have not gone within this condition. So flag variable remain 0 only. It has not been set to 1. So flag is equal to 0. Yes, this condition is true. So now this is what? Break. Now break means what? The loop in which this statement has been written. Fine. When after finding this statement, the control will go out from that loop, or you can say the control will exit from that loop. Fine. So now this statement, this break has been written where? Within this outer for loop, after the closing of this inner for loop. Fine. Within this outer for loop. Now we find the break statement. Now control will go out from this for loop, out from this outer for loop. Fine. Now control will never go to I plus plus. So I value would not be increased to 3. That is why this pass will never get executed. And now maybe here you can write printf, the array has been sorted, something like this. Okay, or you can print that array. See, this case is best when you have a sorted array. Suppose you have an array something like this, 2, 3, 4, 6, 10, 11, 15, 18. Now this is the array, and you are supposed to apply bubble sort to sort this array. This array is already sorted. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. N is equal to 8. Now if you don't apply this logic, if you don't apply this flag variable, then how many times, how many passes would be there? 7 passes. Fine. This program would be executed for 7 passes again and again, but no need to execute for 7 passes because this array is already sorted, na? In one pass only we can come to know that this array is already sorted, because in one pass, when you will start with pass 1, then 2 will compare with 3, no swapping, then 3 will be compared with 4, no swapping, then 4 with 6, no swapping, 6 with 10, no swapping, no swapping, no swapping, and no swapping. And if in any pass you find out that no swapping has been done, then you can say that this array is already sorted. Fine. So no need to do 7 passes, no need to execute this program for 7 passes. Just in one pass only you can come to know that array is sorted. But only if you apply this logic, if you apply this flag variable, then only you can come to know in one pass only that this array is already sorted. So this is the best case. So best case is then array is already sorted. So in this case the time complexity is what? How to find out time complexity? See, how many for loops are there? 1 and 2. So to find out the time complexity, you just have to check out how many times, how many calculations are there, how many computations are there within this inner for loop. So the best case is array is already sorted. So in one pass only you can come to know that array is already sorted. So this loop will be executed for one time only, and this loop would be executed for how many times? For n minus 1. N minus 1 comparison would be there. So the time complexity would be order of n in best case when you apply this logic. But in worst case means the array is given in descending order and you are supposed to arrange the array in ascending order. In that case the time complexity would be order of n square. Why so? Because outer loop would be executed for how many times? N minus 1 times, and inner loop would also be executed for how many times? Approximately n minus 1 times. So n minus 1 into n minus 1, that is, it would be a polynomial function, and when polynomial is there, then we just take the highest order of n. So highest order of n is n square. So we just simply write order of n square. In worst case, time complexity would be order of n square. So in next video I am going to discuss with you the insertion sort. So I will see you in the next video. Till then, bye bye, take care.